The things that we did yesterday, is that the same thing we're doing tonight?
No, you've got the 2 pages right here, studying populations, interactions among living things. Those 2 are homework.
Yeah, that's the same thing we did.
Oh, the same type of page? Yes, you are correct.
So these 2 are homework?
Yes, those are your homework.
Will you read the passage?
Yes, it is. It's gonna now it should all go off of what I'm doing. Okay. Are we ready? I think it's right. Okay. Populations and ecology. This stuff I did not make cards for. It is still on the test. So what I'll do is I'll make some cards that'll be optional and like take a picture of them. So that if you want to be able to do it just easy, you have it. Okay? Okay, here we go. So, we have an organism. We learned about organisms the other day, right? And let's say we're talking about bacteria. Okay? The bacteria is the organism. All of the bacteria together makes a population. Okay? And then if we have like the bacteria, let's say it's in a pond. And in the pond you would have fish and you would have turtle or, whatever. You have all the turtles that make up the turtle population, all the fish that make up the fish population, all of the bacteria that make up the bacteria population. But when you put them all together, they make up a community. Does that make sense? Okay? And then we have all these communities that make up the ecosystem. Okay? An ecosystem, look on your paper, I'm going through those definitions. The ecosystem is going to be the living and the non-living things and how they go together. Yes. Okay? Now, we've got living stuff and non-living stuff. The living stuff is called biotic. Bio. Bio means living, life. Okay? So, all of the living stuff is the biotic factors, and all of the non-living stuff is the abiotic factors. Like not. The anti is a different kind of prefix, and that's just going to go against the, like it's going to kill. Yeah, it's what kills it. Yeah, exactly. Okay, so biotic factors, you're living in once living parts of an ecosystem. So, if we have an organism that was once living, right, it's dead, and what's happening to it? It's decomposing. How does it decompose? Huh? Okay, what are decomposers? What are decomposers doing? Breaking down the things. Thank you. That's what I was looking for. They're breaking down the stuff that's there, that's dead. Okay? Are the decomposers alive? Yes. So, okay, the point I'm trying to make is abiotic is the non-living stuff in the environment. So, if something is dead, does that make it biotic or abiotic? No.
Because it has bacteria.
It's being decomposed, so there's still a living...
Which is bacteria.
Right, are you following what I'm saying? The abiotic factors are the things that can never be alive. Does that make sense? Yeah, like it doesn't, they're made of all the elements, which, yes, we are too, but our elements are put together to make cells which are living. So that's the one little part that can be tricky about biotic and abiotic. Pay attention. Pay attention. And everybody messing with papers, you should be so focused on this because this is the fastest I'm ever going to go. would be like temperature,
Like,
light,
minerals, air,
yeah,
water.
all of those kind of things where they're never going to even be able to live, right? They just go through their functions and everything, and how those interact with the living, that's your whole like ecosystem thing. Okay? Yes. All right, populations. Okay, so we can have a size of a population, and that's just basically how many individuals you have, and then we can have a population density. You know what density is?
That's it. How big is it?
No. Density is how tightly packed something is. Like, you might want to write some of this stuff next to what we have going on. Like, y'all can be adding in notes as I go. That way you can keep up with me. So either you have a space and all the people are packed really close, that would be a big density, or we have a space and the people are spread out, that would be a little density, right? Does that make sense? Thank you so much. Y'all are awesome. Thank you. Okay, and then I'm going to show you in a second the world population density picture, okay? So, if we have the birth rate bigger than the death rate, what's your population going to do? Grow. It's going to grow, okay? Because you have more going in than going out, okay? This is common sense. Y'all should be able to break this down on the test, okay? I mean, like, yes, some of this stuff can lead to it. We're going to talk about that in a second.
Is that what we have like in the in Africa, like we have shaders?
Well, every okay, I know what you're trying to say. Every ecosystem is going to have something that's going to stabilize your population, like normally, but hang on, we're going to get to that. It'll make sense.
Can they overpopulate?
Yes. Yes. We're going to talk about that in a second. Okay, moving on. If the birth rate is less than the death rate,
The population will decrease.
exactly. Okay, this is common sense. That should make sense. If the birth rate and the death rate are equal, then it's balanced. Nothing's happening. It's staying the same. Okay? Because for every one that goes in, we have one that comes out. Okay? But that's not what happens. Okay? Yeah, that's true. So, if we have less food, we would have fewer organisms. More food, we have faster growth. Because there's more resources available, so then they can reproduce and the population can just continue to grow. But the population can only reach a size that matches what's available. Okay, so the world population, like, it's growing fast, way fast. Eventually, we're going to get to a point that the earth doesn't have enough resources to sustain them. And when we talk about that, we're talking about like space, air, water, fossil fuels, like food, land, all of that is in that equation.
Is scientists discover like
No.
there's a movie like that?
But their estimate is 11 billion people. Wait, did I say that word right? Yeah, we're at 7 billion. Yeah, their estimate is 11. That it would be, we've reached carrying capacity. I'm about to tell you what that is. Okay? Resource availability will cause competition. That's a given, right? Like if two lions are competing for whatever, like that, if resource, what we have available is going to cause people to compete. Or not just people, but animals. Okay? And that can affect your rate of reproduction. Like that can affect if they're going to be able to reproduce or not reproduce. I mean, this is all common sense. You just got to think about it, okay? Now, there's two ways populations can grow. Two ways populations can grow. Exponentially and logistically, okay?
Big words.
Big words, it's not that hard. This is exponential growth. This is what it looks like. It's a J-shaped curve, okay? Basically, this is what happens. Let's say we started with 1,000 bacteria, okay? Like, we have a little container, and we put 1,000 bacteria inside of it. An hour later, those 1,000 will all split and make 1,000 more. 1 hour. 1 hour. Okay? 2 hours later, it becomes 4,000.
So this is definitely right there.
We've exponentially grown, yes. You'll see that on a video in a minute, but bacteria shows you like the fast track version, because then within a day you'd have 16,000 or 16 billion bacteria or something, some crazy number. Like,
Can you see it?
yeah, I'll show you. I'll show you.
1,000, now we're 2,000. This is so cool.
It's so cool to watch bacteria grow. Here it is. You ready? It's fast. You ready?
Bacteria reproduce very simply and rapidly by doubling their contents and splitting in two. Just one bacterium, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in 1 day.
See, theirs started like that because they only started with 2. But what I was telling you about is starting with 1,000, right? So that's how you saw them grow right there. That's exponential. Okay, now look, really exponential is not necessarily realistic, because it only really happens when we take an organism and put it into this environment for the first time. Because for the first time, there's going to be a lot of grass, or there's going to be a lot of rabbits to eat, or whatever they're eating. Okay? Like, let's say we took a grasshopper. We had all of this was grass, right? We put our grasshopper population there. Well, the first grasshoppers, they got a lot to eat. So they're going to eat, they're going to reproduce, then those are going to eat, and they're going to reproduce. They're going to be healthy, right?
Until one point, they don't have no more.
Okay, until they reproduce so much that they don't have any grass. You know what I'm saying? That's exponential. That would be exponential. Grow, 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 grow.
And then you won't have enough.
Well, yeah. So that's when you reach a different point. And it looks like this. You just told me it gets to the point where they don't have any more, right? Okay. So they're going to get to this straight line right here, and they reach what's called carrying capacity. This is the max number that can be held or live in that environment.
So we're heading towards that.
We're heading towards that. We're not at that. We're heading towards that. Okay?
People said you should. Or we believe.
No, I don't know.
Hopefully we know.
I don't know. Okay?
What is your graph?
So, look at your graphs on your paper. On the logistic graph, I want you to go ahead and write rapid growth, where the curve is down here. Because that's how logistic is. It's like, don't. We grow fast, we slow down, and then we stabilize. That's what logistic is. Grow fast, slow down, stabilize. So write rapid growth, begin to slow, and you could put stable. RZ, I mean, but what is stable? 1 in equals 1 out. 1 in, 1 out. That's stable. We're just staying. Okay? This line is called carrying capacity. Carrying capacity.
So did we reach the carrying capacity and we go back down?
You could. You could never go back up. But you go down. Yeah. Actually, there's all these little games I've been playing on the internet, and it's if you can get the population to grow and live and all this stuff. Every time I kill the fox, I cannot make him live. Like I've made him live like 1 time.
People said
It's great. I'll put it on one of the things on Blackboard for you to go to. But we're gonna do that like in my lesson for Friday. We're going to be able to put grasshoppers, lizards, and put them at different amounts and try to get them to grow. Like, see what their population would do. Can we make them stay or whatever? Like, that fox one is hard. I kill the fox every time. So, hang on. What causes me, if I'm at carrying capacity, what causes me to be there? Okay?
You don't have any resources.
You don't have any resources. It's called a limiting factor. Look on your paper. That's one of your words. Limiting factor. Something in the ecosystem that will stop it from growing. It could be space. It could be a predator. It could be disease. Yeah, I mean, it could be any of the things that would cause it to just
Natural disasters.
A natural disaster can be too, yes. But a natural disaster wouldn't be 1 in, 1 out. We would probably get a drop from that.
Go back to
Yeah, then the line would end up going back down. Yes, that's a great question, yes.
Is exponential growth practically like in fossil growth? It goes up and then it starts to slow down and then it
Well, actually the beginning of logistic is exponential.
yeah, that's right.
Yeah. The beginning of logistic is exponential because that's when they first get into the ecosystem or to that environment. And that's what it says. It's only possible whenever you first get there, and it's because they have not unlimited, but they have a lot of resources that haven't been depleted yet, basically.
So, at what point in time will exponential growth reach where there's stable?
It can, yes, it can get to that point. And most do. Okay? Most populations go on a logistic curve. Okay? But they're just showing you the difference between the two. And exponential leads into logistic. Okay? I have no idea what kind of questions they could ask you about this. But if it's graphs, they like it. So I'm going through it the best that I can. We just gonna pray to God that y'all don't have to do a constructive response on it. Because we haven't done it enough. Okay? Yes.
Will we not ever run out of options?
No. Yes.
Do you think whenever we reach the carrying capacity and there's there's no more coming in, do you think some schools will have to because there's no more
No.
well, not no more coming in.
When you reach carrying capacity, that doesn't mean there's no more coming in. That means for every one that comes in, one goes out.
And
That doesn't, so that's not the same thing that you're saying. Okay?
So if you have if in your family somebody has
Y'all need to stop right now, for real. Okay. Moving on, and let's tie this into the environment. Okay, here is a picture of the population density for the world. Okay, so you can't see it, but there's like a weird looking white or light pink, but you can't really see those. Okay? The United States is actually not very dense. For the amount of people, okay, for the amount of people that we have, they're spread. That's what this means. But in these other areas, you know, over here and all this, that means in those, they're like packed. It doesn't necessarily mean like, there's a whole lot of people for that amount of area that is there. Okay? Now, we are not like the biggest population in the world. Okay? Y'all let me talk. Let me get through this, and then I'll answer questions. Even though we don't have the biggest population, right, we have what they call the biggest ecological footprint. Okay? Your footprint, your ecological footprint, is the amount of land that it's going to take to feed your people, the amount of land it's going to take to get resources to do other things with, the amount of land it's going to take just for you to have a place to live, the amount of land for our fossil fuels, the amount of water, all the things that, how are we going to get our electricity? You know, all of those things and the materials we make from the land and how much we use. Okay? Hang on, let me finish. So even though we are not the biggest population, okay, our footprint is the biggest footprint in the world. Okay? Which is horrible bad. This is a bad thing. Okay? We are actually in a developed country. So that means that we have, technologies. We have a high standard of living. We have abundant food. Pretty much as much food as you want, you could get. We have cars. We're comfortable, right? Okay. And our population is small, but we still have a bigger impact on the earth than these other populations that are overly, like, there's so many people in one space, but they don't use half the stuff that we use. We are a major impact to the resources of this earth. And if we continue, they say it'll take like 1.5 Earths to keep up with the amount of resources that we use, consume, and waste. Okay, I'm getting to that in a second. Hang on. Y'all give me a second. So, more that the population grows, the more houses we need, the more land we need, the more energy we need, the more resources we're using. As humans increase, we're getting to the carrying capacity. You following me? Okay? This is the different footprints of some of the countries, and ours is the biggest. Okay? It's not only your population growth and size, it's also your per capita consumption. Okay, per capita. That's per individual. In America, each American produces an average of 5 pounds of garbage a day. I mean, that's a lot. Each one of you is 5 pounds of trash per day. When you talk about this stuff, you're not just talking about what it takes to make it. You're also thinking about what it takes to package it, put it on a truck, bring it somewhere. All of that. Okay, plastics are made with fossil fuels. Okay? Your fossil fuels, one of them has like 40 years left. These are estimates. Okay? About 40 years. One of them has about 60 years. So I'm going to be dead But you're going to be the people who could walk into your house one day and flip the switch and nothing happens. I'm going to be gone.
Why don't you live a really long time?
Well, I mean, 60 more years, that's probably impossible. But, I mean, it's going to be you. It's going to be it's y'all's generation that you're going to have to face what's going on. Okay? How can we help it? That's what we're going to talk about. Okay? First thing I want you to do, though, is write down at the bottom, renewable.
Exactly why I wanted to ecology. If anything is made in China, and then it's like most of these things we know, like it's all in the label that says made in China. China uses their resources to make gas safe, so it's still the same in China.
No, but that's the thing. It affects everybody in the whole world. It matters for, like, just because we're doing this over here in the United States, that doesn't matter. Like, that affects them too, because if we're burning fossil fuels, then that's still affecting the ozone layer that is their ozone as well. Like, it's everybody. It doesn't, and this stuff is not just, it can affect the whole, the water cycle, the carbon cycle, the nitrogen cycle, all these cycles that have to function to keep everything working, like, it can affect them all. It can mess everything up. So you have to we want to keep everything working as naturally as possible, because that's how it was made to work from the beginning. Okay, renewable. Number 1, hydroelectric. Number 2, solar. Hang on. I'm going to answer questions. Let me teach it all, and then I'll answer questions. Wind. Geothermal. They're all in this poster right here. But all right is biomass. Okay, I'm going to give you the scoop fast on this. First of all, number 1, whoever the president or whoever is faced with the problem of there's no more fossil fuels, okay, when they're looking for an answer, I'm going to tell you right now, there is not an answer that works for everybody. The only answer that works for everybody is fossil fuels. Okay, so first let's get this straight. There is a good and a bad to everything. Okay, so at this age, all kids, they just want to know what's the answer to the problem. There's not. Okay, it just depends. So let's talk about all of these. Hydroelectric. Hydro is water. The water comes through the dam, it turns the turbine turns the generator makes electricity. It's clean, it makes a whole lot of power. Problem is, you got to have water. Okay? If the people in the middle of New York City they can't get electricity, if we don't have any power, because we've used our fossil fuels, New York can't just, they can't okay? Or in the middle of the plains, if it's dry land, what you going to do? They can't have a hydroelectric power plant. So they've got to have another resource. So it doesn't work for everybody. The other thing is, most places in the United States that can have a hydroelectric power plant do. Okay? We do in Toledo Bend. This could possibly, maybe we could have one in Lake Charles. What would happen, though, is you have to have a high to a low, so somewhere along the lake, somebody's land would get flooded out, and then, because right now the water stops, but it'd have to go up. I don't know. Okay, so that's hydroelectric. Wind turbine, wind blows, turns the turbine, back of it. You can see in that picture over there. The generator's in the back of it. You turn the generator makes electricity. Okay? Wind power is pretty good, but it's an instant thing, you know, like automatically made. The wind turns and then it goes through there and it goes out to the power lines. It's good. Here's the problem. You need a steady wind. You don't have that everywhere. And how are you going to put this in the middle of Chicago? Or you can't put this in the middle of cities. Okay?
You have to have lots of room.
You have to have room.
Would that be good for my thing?
Wait, y'all are all talking at one time. Go.
If a tornado is coming and you have a tornado wind and the wind starts speeding up, would you have more power?
Well, I mean, they have to probably shut them down at that point because they wouldn't want them to
Fly away.
Yeah, or not. They wouldn't fly away, but they wouldn't want them. Yeah. This doesn't store well. Yeah, some of them you can store. This doesn't store well though. It's an automatic feed out. I think that this would be good to put along the coast of Cameron for us because it would come. The distance from Cameron to us is not a bad distance, you know. And now the further it's got to travel, the more you lose heat. It just happens. Can't control it. Okay?
Maybe you ever run out of wind.
No. That is a cycle, the Coriolis effect.
What if you stuck down in the middle of the ocean? In the ocean.
Well, the problem is how far, once it's made, it travels through the wires, and how far, the further it has to travel, you lose as you go. Question? I know I'm not done. I'm trying to keep going. Got it? Okay, solar. Solar panels, they're great. Actually, if you have a solar panel in your house and you feed your house with electricity and you have extra, you can put it back into the grid. It goes back into the grid and the electric company will pay you. Solar panels are great. They cost a lot of money. And you need a lot. You need a lot of panels to run just a little bit of stuff. Okay? No, the sun will not produce electricity. The sun's light hits the panel and there's silicon in the panel and the electrons start to jump and then they run through the wire.
Exactly.
And moving electrons is the definition of electricity. Okay? Geothermal. You have to have a hot spot. Like where you have like earthquakes, volcanoes, and that kind of thing. There's like little hot pockets under the earth. A pipe goes down. We put water into it. The water gets boiled by the hot rocks under the earth. The boiling water turns to steam. Steam turns to turbine. Turbine turns to generator. Generator makes electricity. Okay. Chicago fault lines. Yep.
Is there anything bad with that one?
There's bad things, yeah. If you have a leak and the hot water gets out, oh my, it'll kill everything around. It's hot.
It's like lava.
Yeah, it's hot. Biomass. We actually have a biomass plant here in Lake Charles. It's out by Chenault Airport, by Farmers Rice Mill. When the farmers bring in the extra from their crops, like the sugar cane, the parts that they don't need to make the rice grows on this. They take the rice off, but the other stuff, they don't throw it away. Well, what they do is they give it to the biomass plant, and the biomass plant burns it to boil water, to make steam, to turn a turbine, to turn a generator, to make electricity. Okay? That's a good option. The problem is, not everybody has farmland, right? Okay? And if you do not replant, that is a huge problem to the environment because plants suck in carbon dioxide. And when you take them down, you're putting almost double back because all of that is released whenever it's burned, basically.
So,
okay?
So whenever you take up plants or something, that means
yes, you should always replant. You should always, and that's why they say plant trees or whatever. Because we use so much fossil fuels, we're putting all the bad stuff into the atmosphere, and so if we don't have extra plants to help us take it out, it's not an even, we just keep putting bad in and we don't do anything to take it out. That's the thing. Okay? On your paper, write non-renewable. Hang on, I'm going to get those questions. Non-renewable. Coal, oil, which is petroleum. Petroleum and oil are the same thing. Coal, oil, natural gas. These are bad. They take thousands and thousands of years to get them back. Once you lose them, well, pretty much, because it takes so. We take them out so fast you can't get them back in fast enough to keep up with it. Okay. Another few bad things about this. Okay, you use oil to make plastics. So every packaging that stuff comes in, you had to use some kind of fossil fuel to make that.
So we basically run off of fossil.
Yes, we run off of fossil fuels. How do you get the gas into your car? Boom. Right now, for us to get electricity, they burn that stuff. Yeah. And then to get natural gas out of the ground, y'all need to go look this up. Fracking. Fracking. Where they do fracking, they go like crack the ground so they can get the natural gas to come up. And think about it. When you crack something, can you really control where it breaks?
No.
So this natural gas, it like leaks out in places. And the people who have fracking around them, they can go to their faucet and light it on fire. Swear to you. Go look it up. There's videos all on YouTube. They don't want to do that.
No. How do you light? Wait. They're drinking gasoline.
Because where they were fracking, it cracked into this ground, and that gets into your groundwater. So when they go to the faucet, like I swear to you, the faucet, like the dude's holding his water hose like this, water's coming out, he lights it, turns off the water, it's still on fire. Swear to you, go look that up.
What is it like a fire? What about moles? Like when moles dig in the ground?
What are you talking about?
When they like dig in the ground certain places, does that cause fracking? What if it's
No, this is like they have to drill pipes down to go in there and get the no.
I can't move over. You move over.
Hang on.
It's not my fault this bus is so crowded.
Dear Tim and Moby, how many people can fit on the Earth? From money. That's something Moby and I are wondering too. But it's not really a question of how many people can physically fit on the Earth. The issue is whether or not Earth has the resources to support all of us. Not all of the world is as packed as this bus, but like the bus, the Earth has a carrying capacity. That's the supportable population for a particular place. That's a relief. A population is the total number of individuals of a particular species in a particular area. Our planet can only support so many populations at once. Our species, Homo sapiens, came on the scene a couple 100,000 years ago. The human population grew little by little, but then, 200 years ago, everything changed. The population exploded, and the Earth is having trouble keeping up. We're using up natural resources like fossil fuels and producing a whole lot of waste. And human activities like clearing forests have a harsh effect on our animal populations. Why did the population explode? Well, around that time, there were many improvements in medicine, sanitation, and nutrition. More people started living longer, and more babies survived to become adults. These adults had more babies, and so on. Usually for a species, this is a good thing, but as far as resources go in some areas, humans are really starting to push the limit. Right now, the human population is a whopping 7 billion people or so, and that number gets bigger every minute. It's expected to pass 8 billion in the 2020s and 9 billion in the 2030s. In order to support all those people, we're really going to need to make some changes. Well, there are plenty of things that we can do to reduce the amount of resources human beings are using. We can reduce our water and electricity consumption, stop over-packaging factory products, and work on alternative energy sources like solar power and wind power. There you go. Recycling is a great way to reduce the amount of resources we use. Although it might be a good idea to drink the soda before you try to recycle the can.
Okay, so Janie had asked the question, like, what do we do about it? Basically, you know, once y'all get to the age where you can vote, y'all are going to have to choose to do things that are good for the environment, okay? At this point right now, you can just encourage, like, recycling. You can use less water when you brush your teeth. Y'all, it takes electricity to do everything. I know, like, people are like, but if there's more water, the water cycle is going to continue, we'll have more water, right? But you have to have electricity to pump that out of the ground, right? And then get it into your home. So it takes electricity to run. Don't run keep the lights off in your room. Don't run your thermostat on so high. You know, if it's winter, wear more clothing and use blankets, and don't run it, you know, don't run the heater so much. Like, all these little things, even though they seem really small, they can end up leading to bigger things. In other, like, bigger cities, they carpool to work. You know, like, it's a big thing. The less cars we have, you know, the better. They're going to make, you know, maybe you want to get an engineering job where you can make better cars that, you know, an electric car, it's a good thing, but think about it. Yeah, you might not be using the fossil fuel for gas, but you still had to charge it. And to charge it, you had to use electricity. So I'm not saying it's good. I'm not saying, but there's still ways that y'all can make it better, and y'all are just going to have to make it better. Y'all are going to have to look into ways to do things better. You know, that's why they're trying to make vehicles to where we can have flex fuel. It has more alcohol added to it says E85 or whatever, like it's an 85%. Like it has more, but then the motors run different. I mean, it's just there's a cause and effect to everything. I'm sorry.
What is the smallest, like, footprint?
I don't know. I didn't pay attention to it.
I couldn't read it.
Pakistan had 0.6. Huh?
Could we create a water-based motor using water?
There is a hydrogen fuel cell which does work off of something like that. I don't know all of the mechanics behind it, but a hydrogen fuel cell would involve something with water. I don't know if it would be enough of a power source to run a vehicle, but there is something we do use hydrogen fuel cells for things. Okay, so tomorrow you have 2 pages for homework. You had 1 page last night, you have 2 pages tonight. That's 3. Tomorrow I'm going to go into their relationships and the food webs and food chains, which hopefully you all already know about a lot. And then we'll do that interactive thing on Friday.